got a cumulative frequency graph to deal with at the start of this question, and just reminding you, the cumulative frequency is a running total. So if I look at this point here, it basically tells me that approximately, because I don't have all the data, but I would expect that there are 30 people less than or equal to 160 centimeters in height. So you can see that's what I mean by the running total. Now it's always, whatever the point is, it's less than or equal to the value in height. And that's going to help us find the median, because the median I'm interested in where 50% of the people are less than or equal to a certain height and 50% are above. And the position is going to be 120 divided by 2, or 60. Now, when we deal with this kind of data, it's not the same as for listed data. We don't add 1 to the value. Like if you have some numbers, 2, 3, and 10, the median is obviously the second value, but you can do the number of points plus 1 divided by 2 to give you the second value, to give you the position that you need to look at, which is 2 in this case. For cumulative frequency, we don't tend to worry about adding 1 to it. We just go with dividing by 2. So anyway, we're looking at the 60th person, and what we can do is read off the graph. And you should use a ruler for this, and you should do it really as accurately as you can. And I'm going to demonstrate that. So 60, and then I'm going to read down, and I'm going to read off 172. The interquartile range is equal to the upper quartile minus the lower quartile. And the upper quartile, whilst the median is halfway through the data, the upper quartile is 3/4 of the way through the data. So it's going to be 3/4 times 120, which is 90. And meanwhile, the lower quartile is 1/4 of the way through the data. 1/4 times 120, which is 30. But that's the position, just like I had the position for the median. So I'm going to need to work out the actual values of the upper quartile and the lower quartile. Okay, so I'm going to read off 90. And this one is kind of a bit harder to tell. I think it's actually in between 176 and 177. I'm going to read it off as 177. But some tolerance would be given there. And then for the lower quartile, I read off from 30, and that's a bit easier to read off. It's just going to be 160. So I subtract them, and that's going to give me an answer of 17 centimeters. What that tells me, in fact, is that 50% of the data is within these two values. It gives me a good measure of the spread. But I'm not going to say any more on that. Okay, finally, calculate the percentage of the members who are at least 180 centimeters tall. This time, I'm going to read up from 180. And I see that I've got 100 people, but that actually tells me that I've got 100 people that are less than or equal to 180 centimeters. 100 people are less than or equal to 100 centimeters. And actually what I'm interested in is this distance here, which is just 120 minus 100, or I can just read it off. 20 people are at least 180 centimeters. Now it doesn't ask me for the number, it asks me for the percentage. So it's going to be 20 over the total number of people times by 100. 20 over 120 is 1/6. 1/6 times 100 is 16.6 recurring. So I've written down the exact answer, and now I think I'll round it to, it's only approximate, so I'm going to write it down to 2 significant figures. You might write it down as 16.7 instead. Okay. onto a histogram linked into this question. So we're now given a histogram about members of a swimming club, whereas before we had cumulative frequency for members of a rowing club. And then we're asked, which club has the greater median height? Well, let me just remind you, we worked out the median height of the rowing club and it was 172. So I need to somehow show if the median is bigger or less than or the same as this one. Okay, to work out the median, we're going to need the median position. And to work out the median position, we're going to need the total frequency. How can we get that from the histogram? Well, the frequency density is equal to the frequency divided by the width. That's its definition. We plot that because when you have unequal widths, it's misleading to plot the frequency, because if you have a really big width, a really big group with a big width, then you're going to get a higher frequency than you would if you had a smaller width, for example. So we scale it down by dividing by the width. That means that I can work back to the frequency by rearranging and finding the frequency density times the width. And it's actually the area of each of these bars. So that's what I need to calculate, the area of each bar. Okay, the first one is going to be the width, which is 20, times the height, which is 1.4. And that's going to give me 28. Let me find the second one. The width is now 10, and the height is 7.4. I've got 74 people in this bar. Okay, next one. I've got a width of 10, a height of 3.6. I've got 36 people here. And then finally, this one is the trickiest to read off, because it actually looks like it's less than 0.8, but it's more than 0.6, but it's also more than 0.7. So you'd probably be given some tolerance here, but I'm going to treat it as 0.8. I'm going to write down that it's 20 times 0.8, and that's going to be 16 people. So the total frequency is going to be 28 plus 74 plus 36 plus 16. I actually did this question before, but I read it off as 0.7, but the mark scheme actually goes with 0.8, so I'm going to return it to 16, and I have 154 people. Okay, that means the median position is going to be 154 divided by 2, which is 77. I remember seeing in the mark scheme that 76.5 was accepted as well. Maybe if you went with the 0.7, I'm still trying to get my head around this. But anyway, I think a few values would be accepted. I've got 77 in this case. All right, so where does that leave me? I'm just going to draw return to a grouped frequency table to relate it, because this is typically where you deal with the median. So I've got the height being between 140 and 160, and I have 28 people with that. Then 160 to 170, 74 people. 170 to 180, 36, and 180 to 200, 16 people. And when you tend to find the median from this, you tend to say, right, well, okay, it's not going to be in the first group, and then, oh, it's going to be in the second group, because you can kind of see that the last person in this second group is actually going to be the 102nd person, and the first person's going to be the 29th person. So I can see for sure that the median is in this group. And actually, that's going to be enough. The median will be in the 160 to 170 class. And we know that the median for the rowing club is 172. So this is going to be less. So the rowing club has a larger median. Okay, a few things. I didn't actually need to draw the grouped frequency table. I could have seen it directly from the histogram if I've got my understanding of that. I simply drew the group frequency table to relate back to a topic that you should have seen. You should have covered finding the median class from a grouped frequency table, and I can see that it is going to be in this one. Hopefully you're happy that I've done enough. Because I can see that the median is going to be less than 170. It's clear that the median for the rowing club, which is 172, is more, and we've done enough here. Just a little bonus bit though, like I'm still trying to figure out on the specification whether you will be expected to actually calculate the median or estimate the median. So I'm going to talk about how you can do that. It is a topic on A-level for sure, and it's worth talking about. So let's estimate it. I know I'm looking for the 77th value. So what I can do is I know there's 28 in the first group. I can do 77 minus 28, which gives me 49. So the median position is the 49th position in the 160 to 170 class. Now I know how many people there are. There's 74. So it is 49 over 74th through this class as a fraction. That's not a particularly nice fraction, it's got to be said, which makes me think they don't want you to do the question this way. But it's actually going to be about 66% of the way through the class. So if I was estimating it 2/3, it would be about here. Okay, this would roughly be my median. But we can do better than that because I know I've got a height of 10 centimeters through the class. So I can do 49 over 74 times the width times 10 centimeters. And that will actually give me how far through the class I'm going. And it's going to be 6.621. How far the median is into the class. So finally, I know where the class started. It started at 160. So actually, the median is approximately equal to 160 plus this 6.621, which is approximately 166.6 centimeters. That is how we can actually find an estimate for the median from a histogram. Something to be aware of if you see this kind of thing in GCSE or later on. We can actually not just say where the class is. What we've done here is we've used something called interpolation, we've estimated the fraction of the way through, and then used that to get the approximate position. The reason that it's approximate is because we're assuming that all the data is evenly spread. I don't know that. I might have all my data bunched up at 168, for example, in which case the median would actually be higher. I'm assuming a lovely even spread, and then I'm going 66% of the way through that. I don't know that for sure. It's the same when you're finding the mean from a histogram. You just don't have the exact values anymore. Anyway, that took quite a lot, and you can see that that wasn't expected in the question. If you're happy with the main bit, that's great. I'll do a little smiley if you're happy with that. There's a lot going on in this question. If you are happy with this, and I would say practice some more, then double smiley for you.